In this video we're going to look at finding the value of z using tables of the normal distribution. So these are going to be looking at problems where we are given a probability and we wish to sort of work backwards to see how that links to the standard deviation. So this first question, I'm told here that the probability that z is greater than a is equal to 0.2, and in this case it's a that I'm trying to find. So what standard deviation, if exceeded, or how many standard deviations away from the mean, if exceeded, will give us a probability of 0.2. Now actually I can use this small table of the normal distribution here, because this gives me probabilities here in the first column and relates it to a z value here. And these are for values where this probability, if exceeded, is exceeded by this value here. So obviously, as you can see, there's only a limited number of probabilities this is useful for, but 0.2 is one of them that is here. So 0.2 is here, and I can see that the associated z value is 0.8416. So this first one I can just simply write a is 0.8416. So this next one, find the probability that z is less than a, is 0.4, find the value of a. So I'm actually going to do a sketch here. So I know the probability that I'm looking at is 0.4, so it must be before the mean, because otherwise it would be greater than 0.5. So that area there represents something that is less than a is 0.4. This isn't going to be useful though, because it's the wrong side of the line and we only need to have ones that are positive, so I can use symmetry to tell me that actually it's the same as this area here. And I do realise that these sketches don't exactly look symmetrical because of the way I've drawn it, but it is a sketch here. Now this I can look up because this has an area of 0.4, so I can use my small table again, and I can see that the associated probability, the associated z value here is 0.2533. So I can say here on my sketch this is 0.2533, and then by symmetry I can say, well, actually the value I wanted for a then must be negative that, because it's just the other side of the line, so negative 0.2533. So now I'm looking for the probability that z is less than a equals 0.6. So I'm going to do a sketch here. So 0.6, this must be above the line. So it's this bit here. This is the value of a I'm looking for. So I can actually use my value that I've just looked up in the last example, because if the probability that is less than that is 0.6, then this white shaded bit must be 0.4, and I've just looked up the corresponding value of a. So here I know that a is 0.2533. Next one, so find the probability that z is less than a equals 0.8810. Now this is not one I can use using the small table, because the small table only has certain values and it will not have this one. So I'm going to have to use the larger table. Now I've got a large probability here, 0.8810. So I'm going to look now in the probability column of this large table, and I'm going to see if I can find 8810, and if I can't, I'm going to find the closest value to it. But I can actually see here there is a probability of 0.8810, which is a z value of 1.18. So here I've got a equals 1.18. So next one, again let's just do a little sketch. So got a very small probability here, so it's going to be down here somewhere, and then by symmetry I can say, well, I know that's equivalent to a very small area up here. Now this I can't look up because it's the wrong side of the line. It has to be below the line if I'm going to use the large table. So what I'm going to say is that this white shaded area must have a probability of 1 subtract 0.0013, which is then 0.9987. So can I look up that? So let's see if I can look up that 0.9987. If I look that up, I find, yep, it's 3. So this value here is 3.00. So my value of A I wanted is negative 3.00. And finally here, the probability Z is greater than or equal to 0.9922. So this is a very similar situation. So we're looking for greater than, so must be up here somewhere, but we're looking at what's greater than, and it's a very large probability, almost the whole graph. So I can then use symmetry to show that's going to be this equal probability over here somewhere. So can I look up this value? Well, let's have a look. Have I got 0.9922? And I can see, yes I do. It gives me 2.42. So that's 2.42, and therefore this must be negative 2.42, and that was the original value I wanted, so A is negative 2.42.